So, we're going to do something today called implicit differentiation. It solves a simple problem for us, and that simple problem is, what if you don't have a function that says y equals? Every function we've taken a derivative so far, it's always been y equals. And sometimes that y is f of x or h of x or g of x or whatever. But it's still solved for y. There's no y's over there messing around with the x's. We're going to run into some situations today where we have a function where we can't necessarily solve for y, but we still want to be able to take the derivative, and that's where we use implicit differentiation. So two quick things. We're going to use implicit differentiation as another tool to take derivatives of functions, and probably the most important thing that you should know is the difference between those three things. Drives me crazy, pet peeve. You all know, right?
Yeah.
Better.
Oh,
Yeah.
yeah.
Good. All right, so here's the rules. This will make more sense when you see me dive into the example. But when I started introducing the calculus, we had that dy dx thing. And I kept talking about that's the derivative of y with respect to x. So we're going to do that, and we're going to treat x as our variable. Anytime that there's another variable in there, we have to treat it differently. And I'll show you how to do that. After we get that mess done, then we're going to do a simple algebra trick. We're going to take everything that's got a y prime in it. I'm going to use y prime instead of dy dx because I find it easier. If you want to use dy dx, you can. Take everything with a dy dx or y prime and move it to the left. Move everything to the right. Solve for y prime. We're done. Easy peasy, lemon squeezy. Really, the only calculus that's going on here is step one. The other stuff is algebra. Or as the French say, algebra. I'm not really sure they say it that way. Anybody taking French? Always taking French in here? Espanol? French? Oui? How do you say algebra in French?
Not sure. I know how to say math.
How?
Mathematique.
Mathématique? It's close to Spanish, matematica. Could you find out how to say algebra for us? I mean, no, not now. There's like a homework assignment or something. Go,
Oh, okay.
you know, call somebody you know who's French. Or ask you, what period do you have French? Beautiful. Okay, you're good.
Okay.
All right, so here's this bad boy. I don't think any of us know how to solve for y in that case. And obviously, if I gave you a function like y minus x equals 4, you would just move the x to the side and differentiate. This one doesn't work out so well. Best part is Lexi will have your coughs caught on the recording so we can go back and listen to you. That'll be awesome. Everybody else will be watching the video like, Olivia's gonna be like, what the hell is that? No, oh yeah, that's Lexi.
Now they know who it is.
Yeah, well,
Great.
they didn't know until then. So I'll just edit that out, don't worry about it. Okay, so here we go. If you take a derivative with respect to x, you just, sorry, let me rephrase that. If you take a derivative of x, you just treat it like a plain old derivative. If you take a derivative of y, you got to stick in a little extra sauce on that one. So 3y squared, take the derivative like you do normally if it were x's, but when you're done, you got to stick a y prime on the end. Exactly. 2y, y prime. I took a derivative of something with a y, using our normal derivative tricks. Stick a y prime on the end. Minus 5, y prime, minus 2x. Okay. No y prime.
No, what?
Now technically what's happening is, let's do a sidebar here, kids. I like y prime because it's easier, but what you're really doing is you're sticking a dy dx in here. Okay, because I took a derivative of y with respect to x. There's nothing on here because what would I be doing? I'd be taking a derivative of x with respect to x. What's dx over dx? 1. So we don't, it's like writing 1x to the first. It's just, it's bush league. We don't do it. Okay, what's a derivative of -4? 0. That simple little step there is the most common mistake that people make with implicit differentiation. As nasty as these things get, that's the most common mistake. They'll leave a -4 on that side. Okay, we're done with calculus. I mean, not for the year, just this particular, every day's a treat day from this point on. By the end of the year, we're all like 450 pounds. Hello, Miss Class. Donuts.
Crappy son.
That's why I'm now.
She's like crappy son intravenously. Plug me in. Okay, now we do some algebra. If it's got a y prime, you leave it on the left. If it doesn't, you move it over to the right. Now, you're all pretty smart fellers. You probably could skip this step and go right to the next step, but again, going slowly first. Divide. Beautiful. Solve for y prime. Y prime is equal to this mess. And we're done. Yes, Kevin.
So every problem, is every problem going to be x over y for the answer?
Not always. So now if we wanted to know the slope of the tangent line, you could put in x and y, do all this other fun stuff, go from there. Wouldn't it be nice if it was that easy?
Yeah, but I was feeling it's not.
What it's not. How could we make it more complicated?
Combine the
Another-
y's and the x's.
Another variable.
The second derivative.
Another variable would be really nasty. That's for later.
Like 2 months later.
No, in a week or so.
Oh, fun.
And fractions.
We start doing related rates problems.
I don't know what that is.
Oh, it's my favorite lesson of the year.
Price of
It's a blast. How else could we make it more interesting?
Add some chain
Fractions.
rules.
We could add some chain rules.
or multiple.
And while we're at it, let's throw in a product rule or maybe a
What
quotient
about
rule.
all 3?
What if we were to take the derivative of that? Don't look at me like that, Abby. I can feel the scorn coming out of your eyes. Let's take a second derivative, shall we?
You won't.
Why?
You won't?
Let's do it.
Okay.
Mr. You have a question for
That's probably why you have your hand in the air.
you. Yeah.
Go ahead.
What happens when you combine terms though, like x's and y's?
Patience, grasshopper.
That's good.
I really don't like that.
It's basically the same thing.
Wait, that little guy sitting right there. That little guy? Oh, no. Oh, I guess we can't do it now. Just kidding. That's a 2? Okay. So now we're going to do y double prime. Hopefully you recognize by now, after my ramblings, that this is going to be a quotient rule. And this is going to get ugly. Derivative of the bottom squared. Sorry, not the derivative. The bottom of the derivative is what I meant to say. Squared. Oh, we're going to need a bigger Gazinta line. Bring that up to the top.
Yeah, is that what that's called?
Times the derivative of the top. So what's a derivative of 2x? 2. With a y prime? Oh, I couldn't fool you guys. I could have fooled some of you probably. 6y, y prime, plus 2, y prime. Come on, that wasn't so bad, right?
But now you're going to combine terms. Why are you smiling?
I don't know. We could combine. You want to combine terms?
I mean, you have to.
We could. We distribute the 2. That's easy. We could all distribute, right? We're good at distributing.
These numbers
Wait.
don't get along here.
That's good. What happens when we distribute over? Ooh. All right, I can do this. 12xy y prime minus 4xy prime. Oh, oh no.
Whoa.
Whoa, 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 whoa. Easy there, mad dog. Y prime over 3y squared plus 2y minus 5 quantity squared. We could probably stop there, couldn't we?
No,
Yeah.
no.
You can't combine like terms. There's nothing to combine in the top.
You gotta plug in the y
Yeah.
prime.
Oh no, we know
No,
the way
no, we
from
have to stop there.
Wait.
No, make it stop.
I remember this.
don't want
Easy.
I don't want to see that.
You could technically.
We
go
could
for
stop
it.
there, or since we know what y prime is, because we just did that and it's right below, we could take y prime and put it in there.
Yeah.
Like, I feel like that just
If
would
we're
be
feeling
bad.
suicidal.
This will be fun. Okay, now, there's a couple things that we need to worry about when simplifying functions. This, depending on what you're gonna do with this, you can stop here or you could go further. I'm not gonna go further. I'm gonna stop, oh, shut up. I'm gonna stop here. However, if we were to plug it in, notice we would get a fraction within a fraction. Fractions within fractions for answers are never acceptable. So you would have to do a little bit more algebraic manipulation to get rid of that fraction within a fraction. And how do you do that?
Multiply by 1.
And multiply by 1. So we multiply by 3y squared plus 2y minus 5 over 3y squared plus 2y minus 5. Okay. That was fun, wasn't it? Let's do another one. Let's try something else. Let's see what the next slide holds. Oh, it did. That's nothing.
Bush League.
Yeah. There we go.
What?
Oh, yeah. This is happening.
Oh, yeah. Oh.
What'd you say?
It's making my head spin.
Okay, so we want to determine the slope of the tangent to the graph of blah, blah, blah at the point 3, 1. So we don't even have to do the full tangent line. We're just going to find the slope, which means we need to take the derivative. Do you know how to solve for y there?
No.
No, nor do I, so we're going to use implicit. What do we got going on with implicit here? Why is this going to be a ton of fun? Edie? One thing we got going on is some chain rulage.
10x or 100xy.
That is over there also, yes.
That's 3.
So you just want to do identify the 100xy, or
Well,
do you
no.
want to make a comment about it, or just?
The x's and y's are combined,
Which means?
that you can't eliminate them right away.
Which means? Not quotient rule. Product rule. This is going to be a blast. In fact, I'm changing colors. I'm going to red this time.
Ooh.
All right. Abby, you want to help?
Not even.
Come on, you coward! You want to do the left or the right?
I don't want to do either,
But if you had to do one, which would you prefer?
if I had to do one, I hate starting on the right, so I guess the left.
Okay.
Okay.
All right.
Alright.
What do you got? How many functions?
2,
Outstanding. How many chains?
1.
One, which is unfortunate because I like to say 2 chains. Anyways, 1 chain.
You're right.
It's getting old, isn't it?
I wasn't even here.
Oh, yeah, so, but you're not coughing now. But you will now that I mentioned it.
Yeah.
Watch.
Thanks.
Within 30 seconds, she's gonna cough. Go ahead.
Okay, so it's 6, right?
I like that. It's a good start, Abby.
Times x squared plus y squared.
Love it.
And that's like 2, 1, but.
Yep. Yeah. We're all
And then-
mature adults here.
Yep, and then it's times, right?
Do you want the dot there? Or would you prefer just a
I
parenthesis?
prefer the parentheses.
All right, I can do that.
Personal.
Uh-oh.
Why did you go?
Why not both?
Swing and a miss. Strike 1. I thought I switched to red.
And then.
Hold on.
Okay.
I'm gonna go America. There we go.
And then 2x plus 2y. I think.
Screams freedom
Y prime.
And then.
I'm sorry?
Y prime.
Y prime.
There it is.
Oh yeah.
I forgot about this whole
Yeah,
school
yeah.
thing.
Uh-huh.
And then I wanna call it a day on that side.
You're done on that side.
Nice.
Well done. Let's give it up for Abby. Huh? Dennis,
Yeah.
you got the right side, buddy.
That's what it is.
Do you care about the 100?
No.
No, I don't either. We'll just write it over here and leave it there, like your little brother that your mom told you had to take with to the playground.
Yeah.
Set him on the bench. Make sure he doesn't hurt anybody.
Fine.
All right, how are we taking the derivative of xy?
Okay, so x would be 1. And then times, or, yeah, wait, yeah. Times, y prime.
Nope, not yet.
Oh, just y,
Just y. Why?
because it's derivative and then the,
Derivative of the first, which is 1, times the second, which is y.
and plus, and x, y prime.
Close parentheses?
Yeah.
Nice. Let's give it up for Dennis.
Why did it happen?
Where's the first one? Where do you get the?
Good question. Why did that happen?
Product rule.
So the 100 doesn't matter, so you just set that out in front. Took the derivative of the first, the derivative of x is 1 times the second, that's where the y came from. Then took the first times the derivative of the second, the derivative of y is 1, but because you took a derivative of y with respect to x, you gotta stick a y prime on that. Okay, we're done with calculus. Now we do some algebra. This could be the bad part. I need to get this y prime out of here and over there, and I need to get that y prime over there without that other gunk.
Whoa. Well, wait, what did you,
How'd I do?
what did you do?
Okay, good. What did I do? I took the blue stuff and multiplied it by the 2x. Right, 6 times 2x. And I don't want to bring that, I guess I could bring that 12x into the other stuff, but
Oh, so you just skipped
I just did 1. And I took the blue stuff and multiplied it by the 2y prime. And I distributed the 100. Okay. So, this stays, this goes. This stays, this goes. That'll work really well on the video. 12y prime times x squared plus y squared. That stays. Bring this other guy over here. Minus, close parentheses, minus hundo xy prime. Okay, that's all the stuff with the y primes on the left. That makes me happy. Everything else goes over on the right. The 100y stays there, and bring over that 12x times x squared plus y squared. How are we doing so far?
I'm barely holding on, but let's keep going.
That's okay. Any problems before I continue? We're good?
Sure.
Okay.
Just get those.
Now what?
Get those y primes out of here.
Factor out that y prime. Let's do it all in one step. I'm feeling saucy. Huge melon is in the way.
Well, you can. Looks like you can reduce.
Let's just wait. Oh, yeah. Is that it?
That's it.
We're done.
That's about it.
Well, you can reduce it.
Well, I could take out a 4 out of the top and a 4 out of the bottom. Make that 25y minus 3x, blah, blah, blah. 3y, blah, 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 minus 25x. But
Can you get rid of the x?
we all know that.
No, this subtracts.
You know what would make this funner?
The second derivative.
Second derivative, let's do it! Nah, just kidding, I don't wanna do that.
Would that be an acceptable form for the answer?
That?
Yeah.
Yeah.
Okay.
For much
So
longer.
that's the slope.
Yeah, it's a slope.
What is
Wow.
the
Well, no, that's the equation of the slope. We still haven't answered the question
You
yet.
gotta plug in 3.
Gotta plug in 3 and 1. Go ahead, I'll wait.
So you wait.
What's that?
Negative.
So what that simplifies to?
Yeah, 13 over. Wait, 13 over. Yeah, 13 over 9. Negative 13 over 9.
Over 9?
Wait, I don't
No,
know.
I think it's
Negative 13 over 6? Over 9?
13 over
Positive.
Positive.
Positive? No, negative.
Negative?
Negative.
That's right.
Negative.
I'm going with negative.
I'm just gonna keep saying the negative. Negative.
Wait, no, it is positive.
It's negative.
It's positive.
Positive. Negative. 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 Negatory Ghost Rider. The pattern is full. Hundo minus 360. Hold on a second. 120 minus 3 hundo.
That looks like positive to me.
Well, if you had
Negative.
If I had that other 0, it is.
Oh.
Negative 260 over negative a $1.80. That looks positive.
Looks it's
26, 13 over 9. Whoa.
That was rough.
That was fun, wasn't it?
Is
I
that
feel like you could just like plug that into your calculator and just
Look, what did your calculator?
that. I don't know.
The original function. Just keep hitting buttons until it.
Yeah.
I'm almost there!
Left side, right side, intercepts.
Do calculators take derivatives?
Kinda.
What does that mean? Like you're kinda.
Well, they kinda do.
They find like.
They won't tell you what the derivative is, but they'll tell you what the function value is when you put in if you, like it'll tell you what f prime of 2 is. I'll show you how to do that later. This was fun, right?
No.
Poopy
Just like a lot of
What would make it more funner other than the second derivative?
The third derivative.
How about some trig?
No.
Yeah, come on, I lied. We're just gonna stop there.
That picture is.
Anybody see that picture moving?
Yeah.
How many don't? Interesting. Okay. Some people do, some people don't. It depends on how your brain works.
I don't
You're still in shock from the lesson.